Today we're going to build a DIY rotating time-lapse base for our GoPro camera that senses whether or not there's someone in the room. The concept here is simple. People love to shoot time lapses around people working or in workshops where projects are getting built. But at some point, often the subjects just leave and then they come back in a couple hours later. And if you were trying to shoot this time lapse with motion, you basically end up with this huge section in the middle you have to cut out. And then the camera jumps from looking over here to looking over here because that middle piece, when everybody went for lunch, is missing. So the idea here is to create a rotating time-lapse base that as soon as everybody goes away for lunch, it stops moving. Now we don't have control over the GoPro camera, so we will still have to go back and delete all of the photos when the time-lapse when people weren't around, but at least it means that our movement will be consistent because the movement will continue as only when people come back in the room. We're going to be doing this using two different kinds of sensors. We're going to use a motion sensor to see when there's motion in the room, and we're going to use a sound sensor. Here, the case is just hopefully that one of the two is going to be able to pick you up. So maybe you're out of like where the motion sensor can pick up, but at least you're going to get picked up by the sound sensor because we don't really want false triggers with this. We really only want it triggering off when you leave. The parts of this project came from a Raspberry Pi parts kit sent over to me by HSU. They've got this super cool electronic kit that includes everything you need to get set up and started programming either an Arduino or a Raspberry Pi, except for the Pi or the Arduino. It comes with a ton of sensors, a couple breadboards, all the hookup wires, all the cables you need. Absolutely everything you need to get started is in one of those kits. And well, it's not the cheapest way to go about learning to program. It is a pretty neat way to get into electronics because there's a bunch of possibilities there. It's one of those things that you go through the list of sensors and it's just like, oh, I could use this for a neat project. I could make a tripwire using the laser and the photocell. I could make something that avoids obstacles. There's a ton of different possibilities, and sometimes having all of those sensors in front of you is a much easier way to brainstorm your next big project than having to think about them and then go order parts. So a super cool kit. It was inspirational in coming up with this project because I was going through it being like, oh man, I got a sound sensor and a motion sensor. How cool would it be to make a rotating time-lapse base that only rotates when you're around it? And that is what we're going to do today. The camera movement is going to be controlled via two servos. These are just little hobby RC servos, small, low power, but definitely powerful enough to move around our GoPro camera. We're going to have a quick go over what's happening here on the breadboard. If you want more in-depth guide on this, as well as all the code that runs it, there's an unlisted video down in the video description that you can find that has all of that. So basically, we've got the Arduino over here that's powering everything. We've got two different sensors. This here is the motion sensor, and this guy here is the sound sensor. And you can see when we get sounds, that little green LED down here blinks, and that means that the sound signal has been triggered. The thing's being powered by 12 volts of AA power. That 12 volts runs into the V power, or the power in on the Arduino. The Arduino then converts it to 5 volts to drive the two sensors. Now the servos are being driven off of the LM317 chip over here, just because, well, you can drive one or two servos off an Arduino. The best practice is to power them externally, so that's what's going on here. This little 317 chip is just bringing down the voltage from 12 volts to about 6 volts for the servos. So overall, how the code works is that if there's a signal, either positive from the motion sensor saying that there's motion in the room, or if the sound sensor thinks that there's sound in the room, these servos keep working their way through its panning motion. But if the room goes motionless and quiet, both of those factors have to be true, then the code shuts down and pauses the rotation of the sensors, or of the servos. So I've just started the process of moving everything from the breadboard over onto the perf board here. I've got a whole bunch of these little headers that are going to be used to connect to the servo connectors, and I'll use them to connect on to the pins of all the sensor modules, because I do want to place these close to the outside edge of my case I'm going to build, whereas this whole control board can sit down near the bottom. Everything that was laid out on our breadboard has now been transferred over on to our perf board. So we've got power in here via a little switch, which allows us to turn this thing on and off. Then we've got our LED right here with its resistor so it doesn't blow up. These headers here are to allow us to connect to our motion sensor and our sound sensor, while these pins up here allow us to connect to our servos. So the signal pin on these guys is hooked up to digital pin 9 and digital pin 10. Well, the power pins are hooked up to the output pin of the LM386 current or voltage reducer that's wired up on the side here. So that's all of the electronics finished. Now we just got to put this in a case and mount our camera to it. Housing for this mount is going to be built completely out of cardboard, and well, that's really not the best way to do it. It is super fast to work with, so that's what I'm going to use, and it'll just make sure that this first prototype of this project is flexible in the ways it can work. I've been racking my brain looking for a good way to attach the GoPro camera, because I basically need my GoPro to sit on the side of this servo, because this is going to create or control tilt. So this servo is going to get mounted on top of here. This servo is going to control where the camera is pointing, and this servo here is what's in charge of where the camera points tilt-wise. And actually, the way I think I'm going to do it is use one of these cell phone mounts, because they're super lightweight and they'll let me mount onto the side, so that basically I just put the GoPro in here sideways, and it gives me a really easy way to mount my camera while being lightweight. If I was going to do this with the frame and extension bars, I end up with quite a bulky setup. So this is just going to get glued onto the side here, I think, at least for the first try. That's what we're going to do. So there it is. It's the finished motion sensing rotating time-lapse base. Basically, this is just a complicated egg timer that will super slowly move your camera around, and if you want, you can also add in that second servo so it does a little bit of tilting as well. But the idea here was to create something that was a little bit different and had something a little bit special going on. It's easy enough to create a motorized time-lapse rotator. You can use one of the servo, you could get a stepper motor. There's a whole bunch of different ways to do that. The idea here was to do something that was smart, and that if you wanted to shoot a time-lapse around a workshop or something, if you walked off and went for lunch, it would freeze wherever all the motion stopped, and then it wouldn't start again until somebody came back into the room. Somewhere, I guess the next step for this would be to also be able to take control of the camera. To do that, you kind of need to get back-end access into the GoPro app. Not that that's impossible, but it would be a bit more of an endeavor, and something that right now, at least, is a little bit above my skill set. But I could see something like this being super, super useful if you're out shooting time lapses for something like a construction company, where you want to be able to set up a multi-month long time lapse, and then you only want it to be shooting when there's people on site. So you could set up a motion trigger somewhere, and then set the time lapse up, and then only be shooting time lapses when the people were there. But again, in order to fully take advantage of something like this, you would also need a way of controlling what the camera can do. There's a whole bunch of other neat things you could do. You could take control over where the camera's pointing. You could listen for sounds. The possibilities with something like this, when something that you're using to control it is reprogrammable, are basically just endless. Whatever your mind can come up with, you can make with one of these. So it's super, super cool to have something that you can kind of reprogram. I just put it in a homemade cardboard box, my sensors glued on the side, but you can go whatever direction you want with your enclosure. If you've got a 3D printer, you could make something super cool to put something like this in. little bit more sturdy. You could do, there's a ton of different possibilities, but being creative with the way you build things like this is awesome. I had a ton of fun with this project. It's simple in both the way it's coded and how it lays out and how it works. The movement of the camera is really not that smooth. Servos probably are not the best way to do this. You basically just have to make sure that you're shooting long enough intervals in between shots that you let the kind of servos settle back into their position before that GoPro takes a photo. So good for long time lapses, not so great for shooting a photo every half second. You do get a fair amount of jitter into your photos, but the project in itself was a blast. And a huge shout out to HSU for sending out their Raspberry Pi sensor kit. Those things are a blast, and it's just a ton of fun to go through and look at all the different kinds of sensors they've got and just think about the different possibilities and the different things you could make using them. So this was a really fun little project. Not the most polished thing in the world, not the most finished thing in the world, but hopefully it got you inspired to go out and build something cool with your GoPro camera. If you're looking for more details on the breadboard layout or on the code, there is an unlisted video down below that's a little bit longer that kind of walks through a whole bunch of stuff that if you're feeling lost or something, hopefully it's down there. There's a parts list and some schematics down below, but it's super simple. These sensors are cool just because they behave like buttons, so programming it is easy. You basically just have two buttons and you listen for them to turn it off. Easy, easy. Servos were fun. You basically just put in what degree you want them to go to, and that's where they go. So if you've got questions or comments, leave them down in the comments below. But if you've got any other projects or projects like this or other bigger, more elaborate projects you'd like to see me tackle, let me know what those are, because I'm having fun with them. And, well, I don't know. I enjoy making them, so they're probably going to keep on coming. Until next time, guys, thanks for watching.